day. Welcome to chemistry class. Your tutor is Dorcas Adebi, and today's topic is electrolysis. Definition of electrolysis. Electrolysis is defined as the chemical decomposition of a compound brought about by a direct current passing through a solution of a compound or the molten compound. So what electrolysis is about is the decomposition of a compound, usually in its molten form, known as the electrolyte, and this decomposition is caused by direct current that passes through the solution through the electrode, usually positively charged and negatively charged, that is the anode and the cathode. Laws of electrolysis. Faraday's first law, it states that the mass of a substance liberated or deposited or dissolved at an electrode during electrolysis is directly proportional to the quantity of electricity passed through the electrolyte. Okay, the mass of a substance liberated at an electrode during electrolysis is directly proportional to the quantity of electricity passed through the electrolyte. So mathematically we have M is directly proportional to Q. Now we are changing the proportionality constant to an equal to, the proportionality sign to an equal to, and then we need to introduce a proportionality constant, which is Z. So Z is electrochemical equivalent of the substance. Q is current times time, where Q is equal to I times T. I, which is the current, is in ampere, while the time is in seconds. The second law of electrolysis, it states that when the same quantity of electricity is passed through solutions of different electrolytes arranged in series, the relative number of moles of the element deposited or liberated are inversely proportional to the charges on the ions of each of the elements respectively. So the relative number of mole of element deposited is inversely proportional to the charges on the ions of each of the elements. So mathematically we have N is inversely proportional to E. We have that represented mathematically, and the combination of the first law and the second law gives us this, where we have small m, which is mass, over capital M, which is molar mass, or we call it the relative atomic mass, equal to IT, that's current and time, divided by Cf, that's charge and Faraday, 1 Faraday. So M is the mass of the substance liberated or deposited in grams. Capital M is molar mass, I is current, F is 96,500 coulombs, YT is time in seconds. So the capital M can also be said to be the relative atomic mass. Then C is the charge on the ion. Now let's move straight to calculations. Example 1. A solution of copper 2 tetrasulfate 6 is electrolyzed with a current of 6 ampere flowing for 5 hours. Calculate the mass of copper deposited. 1F, which is 1 Faraday, equal to 96,500 coulombs. Copper, the relative atomic mass of copper is 63.5. So we have this formula from law 1 and law 2, which is M over capital M equal to IT over CF. So from the parameters given in the question, m, which is mass, is unknown. Then we know our relative atomic mass to be 63.5. C, which is time, is 5 hours, but don't forget it has to be in seconds. So we've only converted it to seconds by multiplying it by 60, which is to convert to minutes, and another 60 to convert to seconds. The current, which is I, is 6 ampere. The charge on copper is +2, while 1 Faraday is 96,500 coulombs. Now we need to substitute these values into the equation. Now we have m divided by 63.5 equal to 6 times 18,000 divided by 2 times 96,500. So we have to cross multiply and make m the subject of the formula, and that leads us to 63.5 times 18,000 times 6 divided by 2 times 96,500, and that gives 6,858,000 divided by 193,000. So if you calculate that, you have 35.5 grams. So the mass of the substance is 35.5 grams. That's the mass of copper deposited. Example 2. You have 0.66 gram of a divalent metal M is deposited when a current of 1.35 ampere is passed through for 1,500 seconds through a solution of its salt using inert electrodes. Calculate the relative atomic mass of M. So we are to use the formula M over capital M equal to IT over CF. So what I've just done here is to make the capital M, which is the relative atomic mass that we are looking for, I made it the subject of the formula. Okay, so that leaves us to have MCF over IT. Our M, which is mass in gram, is 0.66 gram. The C, which is the charge on the metal, is 2. I got 2 from the word divalent metal. So divalent means a charge of 2. Okay, the 1 Faraday is 96,500 divided by I, which is current. The current is 1.35 amperes times 1,500 seconds. Okay, so that leaves us to 127,380 divided by 2,025. So if you calculate that, you are going to have 62,000.90, and that is approximately 63. So the relative atomic mass of the metal M is 63. Example 3. Calculate the amount of silver deposited in moles when 10,920 coulombs of electricity is passed through a solution of a silver salt. Faraday's constant is 96,500 coulombs. So we have this formula. So we need to find the number of mole. That is what is meant by amount. So we have to calculate the amount of silver deposited in moles. So that's the number of moles, and number of moles is the same thing. The formula is mass in gram divided by molar mass, or you say mass in gram divided by relative atomic mass. Therefore, we are going to change the M over capital M to N. We are going to denote it with N. Okay, so another point we should also note in this question is that we were not given our current, neither were we given time. However, we were given the quantity of electricity. So from the first law, we said quantity of electricity, which is Q, is equal to current times time. Therefore, IT will be represented with a Q. Okay, so this is what we have now. N, which is number of mole, equal to Q divided by CF. Okay, and that leads us to having 10,920 divided by 1 times 96,500. So I use the word as C because the charge on silver is +1. Okay, so we now have this as part of the calculation. The next step is to calculate this, and that will give us N equal to 0.1132 moles. So that is the amount of silver deposited in moles. So we have the following exercises. Please practice them. They are past Waec questions. Practice them and drop your answer in the comment section below. Okay, so thank you very much for watching. Kindly like, share and subscribe to my channel. If you've not done so, subscribe to my channel so you don't miss subsequent videos, and please ensure you turn on your notification bell. Okay, so you can contact me for your chemistry tutorial, and my phone number has been displayed here. So if you need a private home tutorial or you want an online class, I'm available. I'm at your disposal. Thank you very much for watching.